Good morning, everyone. In the last class, we treated electricity. In the lesson objectives, we discussed were structure of an atom, electric current and charges, static and current electricity, alternating current, and direct current. We drew the structure of an atom and we showed the three particles of an atom: the proton and neutron, the nucleus, and the electron at the shell. We differentiate between electric current and electric charges. We said electric current is the movement of charged particles, the movement of electron or proton, but basically the flow of electron, that's electric current. And electric charges, of course, is the accumulation of charged particles. We also spoke about static and current electricity, and we said that static electricity is when electron jumps from one place to another, let's say from one shell to the next shell, while the current electricity is when the electron moves through a wire, that is a conductor. Then we also spoke about two types of current based on the direction of flow: the alternating current and direct current. Direct current moves continuously in one direction, while alternating current reverses its direction periodically. Those are the four that we discussed in the last class. We define an atom, we drew the structure of an atom, we listed the three particles of an atom and their charges. Proton has positive charge, electron has negative charge, and neutron is neutral, it has no charge. And we concluded that because proton and neutron are found in the nucleus and proton is positive while neutron has no charge, then that means the nucleus is positively charged. We define electricity. Simply put, electricity, as I said earlier, is movement of electrons, the flow of electrons between 2 points when there is potential difference between them. Then we have differentiated between electric current and charges already. We have differentiated between static and current electricity. We have differentiated between alternate current and direct current. Then we have an exercise, which is a formation evaluation. You can try them and go back to the notes, the last slides in the video, to see whether you are wrong or correct. So the answer follows. Alright, this morning we are adding two more lesson objectives: the difference between electric field and potential difference, and the difference between electrical components and their symbols. Can you answer the questions below? The path provided in an electrical appliance through which electric current, voltage, and resistance flow is referred to as what? And the second one, the flow of electrons in an electric circuit is known as what? Then the path in which the electrons revolve around the nucleus in an orderly fashion is known as what? What is the unit for electric current? Then what is the unit for potential difference? You can pause the video and answer the questions. Alright? These are the answers to the questions. Number 1 is electric circuit. Number 2 is current. Number 3 is shell. Number 4 is amperes. And number 5 volts. Electric field and potential difference. Potential difference, also known as voltage, is the work needed to move a unit charge between 2 points in an electric field. An electric field is the force experienced by a charge at a given point due to the presence of other charges. Can you see the difference between them? Potential difference. Another name for it is voltage, and it is work needed to move a unit charge between 2 points in an electric field. While the electric field itself is the force experienced by a charge at a given point due to the presence of other charges. Now to electrical components and their symbols. The first one is the symbol for cell. Second one is for battery. The third one is for switch. Then bulb. Then we have resistor. Then the sixth one here is the inductor. And the seventh one is the diode. For a wire, you already know that you draw a straight line. Now let's go. There are some other ones that are not drawn, but this is the summary how to draw them. Look at the battery now. You draw two parallel lines, longer for positive and shorter for negative, as you have seen earlier. You can see longer for positive, shorter for negative. So you know a battery is like two or more cells, the combination of two or more cells. So look at this cell, look at the battery, you can see the difference between them. So in this battery now we have two cells. Then the cell, the switch, wire and conductor is straight line. The resistor is zigzag line. The fuse, the line with a small circle at its end. The diode, I've shown that earlier. Then the ground symbol, three horizontal lines. The last one is the shortest. Then you have a straight line on top, vertical line on top. And I'll show you that of the inductor. Now that is just the two lesson objectives we are adding. So if you can answer the following questions now, it means you have learned this morning. Can you differentiate between electric field and potential difference? Can you list any five electrical components and show or draw their symbols? So you can try that and cross-check. Now before I go, let me show you some likely examination questions. We have the first one here, the flow of electrons in an electric circuit is known as what? The answer is underlined, current. Number 2, the flow of electrons, the same thing. Then number 3, what is the unit for electric current? That is amperes. Then number 4, the material that allows electric current to flow through it is known as what? Conductor. You already know that. Then number 5, the path provided in an electrical appliance through which electric current, voltage and resistance is referred to as electric circuit. Then the device in the circuit used for storing electric charge is what? Capacitor. According to Ohm's law, the current flowing in the circuit is equal to voltage over resistance. And number 8, which of the following is a symbol for resistor? That is G, zigzag line. And number 9, potential difference of 24 volts applied to a lamp of 48 ohms. What current will flow in the circuit? We will use V equal to IR. How I is the current. Then I is equal to what? R over V. R over V. Or V over R rather. That will be 24 over 48, which is 0.5 from Ohm's law. V is equal to I R. Then I equals what's current flow is equal to IR, so I equals V over R. That's 24 over 48, which is 0.5. Thank you. So that is the end of today's class. Please like, share, comment, and subscribe. God bless you.